Hello, my name is Ryan from Buster Beagle 3D, and today I'll be talking about the XTool 40W Diode laser module. It is the newest laser by XTool that achieves the wattage of some of the entry-level CO2 machines. So is this diode laser the CO2 killer? Does it mean it is twice, 4 times, even 8 times better than the diode laser you may already have? Well, let's find out. So first, this 40-watt laser comes as a kit for installing on the current D1 Pro machines. If you already have a D1 Pro in any of the wattages 5, 10, 20 watt, you can use this kit to upgrade. This kit is only listed as compatible with the Pro version and not the original D1 machine. However, if you really wanted to, I'm not really 100% sure why you couldn't install this on the original D1 frame. The frames of the D1 and the D1 Pro seem to be identical, minus the holes for installing the limit switch tabs. This kit comes with a complete gantry, new control board, a power adapter, and even new tabs for the limit switches that need to be installed, so I don't really see any reason why you couldn't technically run this laser without the limit switches, or figure out a way to install those yourself. One thing that I know that would not work is that you would not be able to use your current original D1 laser module anymore, since the wire connection and mounting plate for the gantry is different. Again, this 40-watt upgrade is listed as only compatible with the D1 Pro, but I just thought I'd give you my observation. So to install this kit, you need of course to remove your current module from your machine. The kit also comes with some nice wire clippers to cut off the current zip ties holding on the wire looms. You then unplug the wires from the control board and also unplug the wire from the gantry to the Y-axis limit sensor. You then remove the 5 screws holding on the X-axis gantry and then remove it. You then remove the Y-axis limit sensor and replace it with the one in the kit, which is slightly different and seems to be more robust than the original. You will also remove the tabs of the Y-axis that read the limit sensor and replace those as well with the tabs in the kit. You then remove the coupler that controls the Y-axis belt so you have access to the control board. You then remove the power connector and the 4 bolts connecting the board to the frame. Carefully remove the control board to expose the Wi-Fi connection that needs to be disconnected on the other side before the board can be removed. You then install the new control board the opposite way. Connect the Wi-Fi and screw the new board back in, installing the power connector. You then reinstall the shaft and the coupler, making sure to slide the 2 gantry mounts to the front of the machine frame to make sure the X-axis will be square. If you needed to loosen up the belts to remove the shaft, make sure to readjust the tightness of the belts here before you tighten the coupler to make sure everything is square. Install the new gantry using 5 screws that you removed from before. The kit also comes with all of the hardware you would need to do this, but I just used the hardware that I took off. Be sure not to over-tighten the middle screw, as it's tightening your X-axis belt and you don't want it to be too tight or damage the axis. Plug in the X-axis motor and the wire you had for the limit sensor off of the original machine. Then zip tie the wire loom to the frame and plug in the wires based on the colors. You can now install the laser module on the frame, flip up that metal tab that will hold the wires in place, and plug in the new wires. You can see it has the same connection as the Pro laser with an added connector, which I assume is for the additional cooling fan in the module. Flip the metal tab down and you are now ready to use your laser. So as you can see here, this module is quite a bit bigger than the 10 and 20 watt that you can see next to it. The 10 watt is 13 ounces or 362 grams. The 20 watt is 1 pound 10 ounces or 742 grams. And the new 40 watt is 1 pound 15 ounces or 892 grams. This extra weight is what makes the thicker gantry needed. The 40 watt comes with a new integrated air assist where the hose attaches to it through the top and the nozzle screws into the bottom. They move the laser crosshairs to the rear of the laser instead of the side of the kit, and also it comes with 2 replacement lenses that you can use once your laser lens eventually wears out. They have also addressed the issue with the mounting of the wire connection to the back of the module with that nice metal tab that should hopefully help with the issue people were having where the mount on the back of the module could break the cables eventually with too much movement. The top fan has been replaced with 2 side fans that help to cool the module down. You still have the fixed focus finder switch on the side with the depth adjustment on the side as well to use while cutting. It also comes with a new shield that is magnetic to make removing the shield much easier. Alright, so now on to how it performs. I ran a test where I put the 20 watt and 40 watt head to head to see how it would perform. I ran a simple power speed test to see how they would compare. I also ran a cut test at various speeds to see how fast I could run the laser and still get through this 3mm basswood. If you simply look at the power and speed test for engraving, you can see that the 40 watt laser is able to be seen all the way down to the 10% power mark, and what I thought was 24,000 millimeters a minute at 100% power seemed deeper in the wood than at 12,000 millimeters a minute at 100% power on that 20 watt. Also, don't really pay attention to the fact that the text is very light on the 20 watt, as I had knocked the power down to 20% at 4,000 millimeters per minute when doing the 40 watt, which is just too low for the 20 watt to read properly. You can also see here that the 40 watt laser could cut through this 3 millimeters of wood at up to 900 millimeters per minute, while the 20 watt topped out at about 500 millimeters per minute. I know it seems like I should have gone higher on the 40 watt, but that 900 millimeters per minute circle really needed to be popped out, so I don't think it would have gone much further. The next test I wanted to run was to see the image that I would get with the 40 watt laser. I am not 100% sure about the laser spot size of this module since I have not seen it listed anywhere, but based on this test, I would assume it's fairly close to the size of the 20 watt. This was, however, where I ran into a curious issue. When I went to set up this test for the image of Mount Rushmore, I accidentally sent the laser scan angle at 90 degrees, which means the laser would burn the image vertically instead of horizontally like I normally do. Well, I set this image up for 15,000 millimeters per minute at 50% power, and it seemed to me to go significantly slower than that. After verifying my speed and light burn, I wondered if there was a setting in the Gerbil machine settings that would explain why it seemed slower. Looking at the Gerbil settings, I could see that the value of the 111 was at 6,000 millimeters per minute, which means that the full y-axis or back to front speed you can achieve is 6,000 millimeters or 100 millimeters per second. That means that instead of the 15,000 millimeters a minute, I was burning it at 6,000 millimeters per minute. The more curious value here to me, however, was the x-axis or left to right speed. That speed is listed here at 18,000 millimeters per minute and not the 24,000 millimeters per minute I was burning my test at. That means that there is no difference between the 24,000 millimeter a minute test and the 18,000 millimeter a minute test. Now, why did I even bother to test at that speed? It's because the D1 Pro is advertised at 400 millimeters per second, which is 24,000 millimeters a minute. However, based on the firmware and Gerbil settings, the fastest this machine is allowed to go is 18,000 millimeters a minute or 300 millimeters a second. Not that you ever really want to work at that speed in the first place, which I'll talk about in a little bit, but this is also not a changeable value to the user. You see, and I have talked about this before, that the D1 and the D1 Pro machines are not open source, meaning that you are not free to go in and alter any of the settings that you want on the machine. This also means that the settings that I just talked about are hard-coded in the firmware and not able to be altered by the user. So even if I wanted to change that setting to 24,000 millimeters a minute, it would not write to the machine. I can't change any of those settings and have them stick. If XTool is watching, and I know this is a bit of a tangent and I'll get back to the 40 watt in a second, but they either need to change or make some of these settings usable to the user, specifically the Y max travel that is set at 406 millimeters. That means that if you had purchased one of their extension rails, you would have to press the home button potentially more than one time to get the laser to the back left corner if it was starting more than 406 millimeters forward of that spot. Well, the extension kit is 936 millimeters, so if you were starting from the front of the machine, you would have to press the home button 3 times to reach the back, which might just be confusing to some people. Now, this is in Lightburn, and I'm not sure if they do some fancy thing in Creative Space to overwrite these issues, but I thought I might just bring them up if XTool is watching. Okay, so back to the 40 watt. So in general, engraving and cutting tests for the 40 watt perform well, but I also wanted to see how it would work on some thicker wood. I had some of this scrap pine tree ring left, and I was able to cut completely through 19 millimeters at 100 millimeters per minute in one pass. That is 3/4 of an inch in one pass. Now again, this is not plywood, which would have a much harder time at even half of that depth due to the density and layers of wood and glue and fillers, but it's still pretty impressive. Now that is impressive, but it comes with a bit of a caveat. It really depends not only on what material you are cutting, but also on what design you are cutting. At those speeds and power, you are much more likely to burn or set fire to the wood you are working with. I decided to cut my logo out of that wood, and you can see from the back here that the smaller detail areas kept the laser in the same place for too long, and it ended up burning the wood underneath. It would cut through, but you also don't want to burn what it is you're trying to cut. So now back to plywood. I was trying to cut this 1/2-inch plywood, and I knew at 100 millimeters per minute I would just end up igniting the wood, so I ran the test again at 300 millimeters per minute with 5 passes, and even then, while it did cut through, it ended up igniting the wood deeper down. I tried 700 millimeters a minute with 10 passes, and it almost worked, but not quite. Then I did 1,000 millimeters per minute at 20 passes, and that worked, but again, this is plywood, which is hard to gauge, and in most cases, you still got a decent amount of charring on the side of the wood. The last test that I ran this laser through was color on stainless steel. I ran another power speed test from 1,000 millimeters a minute all the way up to 11,000 millimeters per minute, and I got a bunch of colors. You can see here compared to the 20 watt laser that I can get even more colors at a lower power, which is really cool to see and should lead to some interesting designs. Do keep in mind that this can generate a lot of heat and could warp the metal, so you do need to figure out a way to deal with that issue. This laser is also advertised to be able to cut 0.1 millimeters of stainless steel. Now that is roughly the thickness of a piece of paper, and I'm not really sure why you would want to do that, but you can. I would watch out again for warping, and I'm just not sure it's something that I would be doing with this laser. The last thing I wanted to talk about before I go into the overall thoughts on this laser was to go back to that speed. Now, while engraving at 6,000 millimeters per minute looks great, that little test error under it was at a true 18,000 millimeters a minute. The issue here is that the laser at those speeds can have a hard time switching directions, especially at the weight of the 40 watt laser module. While the laser is much more powerful, that also comes with the cost of that weight. This 40 watt laser is just shy of 2 pounds, and I have some 10 watt laser modules that are less than half a pound. That means that this laser is 4 times as heavy as my other 10 watts. Both the 10 and 40 watt lasers are using the same belt, the same stepper motors, so you can imagine it's harder to travel at a high speed with that greater weight, stop, and then travel in the opposite direction with that weight. I think that is why you get some of that layer shifting that you can see extreme here, but also in places like this where it's more subtle but still there. This was a test I ran through Wi-Fi to make sure it wasn't my connection to my computer that was causing the issue. This was at 15,000 millimeters a minute and eventually lost track in a couple different spots. Also, since I have no control over the Goebbels settings, I can't even try tweaking the acceleration settings or anything like that to try to fine-tune those settings to see if I can adjust it a little bit better. I guess what I'm trying to say is that even though you have more power, it doesn't mean you can go faster given the weight in all circumstances. So this is a good time to talk a little bit about the differences between this machine and a 40 watt CO2 laser machine. Both have the same wattage, but that doesn't make them equal. A diode laser runs at a different wavelength than a CO2 machine, which can produce an invisible infrared light, which means it can cut different materials that a diode laser cannot, no matter how powerful it is. This means that a CO2 can cut things like clear acrylics that a diode laser would never be able to. The other thing is that the laser head of a CO2 is just a reflecting mirror with a lens, so there's no extra weight on the gantry, which allows it to move very fast. However, there are some downsides to a CO2 machine, namely that the laser tube that generates the beam is large and the machine can be very large and enclosed. You also have to have some sort of water or coolant system in these lasers to keep the laser tube cool, which also just makes everything bigger. It's definitely not as portable and lightweight as a diode laser is. CO2 lasers are great if you have the space and can deal with the sometimes smaller workable area, but it really doesn't have the flexibility of a diode laser. Okay, so who is this 40-watt laser for, and should you get it? Well, I think that really depends on the individual and their needs. If you want the best fast cutting ability, then you go with the 40-watt. However, I'm not talking about plywoods here. I think that any laser really just isn't the right tool for thicker plywoods. If you have a solid wood like my tree trunk, it does a pretty good job, but you still might end up with some charring on the sides and the bottom. Where I think this 40-watt really shines is both on the colorability on metals as well as the ability to cut thinner woods at those faster speeds. If you're someone who is going to cut lots of 2 to 3 millimeter wood for little projects and would rather cut at 900 millimeters a minute instead of a 10-watt laser at around 1 to 200 millimeters a minute, then this is the one for you. For the 20-watt laser, I would almost say pretty much the same thing, but at about half the cutting power. With both the 20-watt and 40-watt, you are still going to be able to engrave nicely as well. Now, when you start to go lower to the 10-watt, you still have the ability to cut thinner woods, but you also start to lower the spot size and overall weight of the laser, which means you could potentially run it faster without running into issues. The lower spot size also increases the resolution, as you can fill up an inch with more lines, increasing the image quality. This goes even further with the 5-watt laser that can cut some thinner woods with enough passes, but the spot size gets smaller, which means the resolution can go up, meaning I can get a far more detailed image with a 5-watt laser than I can with a 40-watt laser. This is also why the company recommends getting a 5-watt Pro plus the 40-watt kit if you don't already have a D1 Pro, so you have somewhat the best of both worlds. Again, at the time of this review, the 40-watt laser is not sold as a standalone machine, but a kit for upgrading the Pro lineup. So that's it. I wanted to thank XTool for allowing me to test this 40-watt laser out for you guys and giving my opinion on it. If you like this video, please do give it a thumbs up and consider subscribing for more content. Just with XTool, I have done a review on the original D1, the 20-watt D1 Pro, the RA2 Pro, the enclosure. I have a full tutorial on both Lightburn for the D1 and XTool Creative Space that you can check out in my channel. I have another one on creating tapered images for tumblers, one for using a grid with the machine with absolute coordinates, and a few others, so feel free to check those out in my channel if that interests you. Thanks again for watching, stay safe, and we'll see you next time.